All right, so this would unfreeze. Crap. All right, so this new unit is all about rational functions, rational expressions, rational equations. All right. Now, we're going to do the easiest version of simplifying today, which is just flat out simplifying a rational equation or expression, sorry. So before we even do that, what is a rational expression? So when you think of the word rational, what do you think of? Ratio. Which ratio typically refers to a what? A what? A fraction. All right. So rational expression typically has that x value in the denominator. All right. So if there is an x value in the denominator, it's considered a rational expression. Now, simplifying rational expressions is really similar to just simplifying fractions. All right. So let's first try simplifying a regular fraction. So we're going to represent 18 and 12 as a product of two different numbers, but we want them to be consistent. So what's a number that we know that 18 and 12 can both be divided by? 6. So we're going to rewrite this as 6, 6. 6 times what is 18? 3. 6 times 12, 12 divided by 6 is what? 2. Now, can anyone tell me what's going to happen here? So why did I do this? How does this help me simplify? We can get rid of the 6's. Why? Right. So do you guys see how we have 6 over 6 right here? What's anything divided by itself? 1. So those are gone. And what are we left with? 3 over 2. And that's what 18 over 12 is factored. Or simplified, sorry. Well, with rational expressions, it's pretty much the exact same thing. So if I look over here, now they gave us an algebraic expression. So we're going to basically do what we did with the numbers. We're going to break it down into its factors, meaning we have to factor the expression, and then cross out what happens in both the numerator and the denominator. All right? So x squared minus 9, how would I factor that? Right, x plus 3x minus 3y. It's a what? It's a difference of squares. So this would be x plus 3x minus 3. Now, for the denominator, what's the only thing that get factored out? 2x plus 6. Right, so there's only a GCF in there. It's 2. So what am I left with if I take the 2 out? X plus 3. Now, look between the numerator and the denominator. What factor or factors appear in both the numerator and the denominator? X plus 3. So guess what we can do with them? Cancel them out. We can say bye-bye to them. And then our answer is whatever we're left with. So my answer is x minus 3, because that's what I have left up top, over 2, which I have left at the bottom. So that's why I said you got to be pretty decent at factoring, because most of the time when it comes to simplifying these expressions, you got to factor them first and then cross out stuff that appears in both the numerator and the denominator. Make sense? Pretty easy, right? All right, let's do some more. Now, monomials are a bit different. So with monomials, we kind of have to do it based off of how many x's and y's there are each. So let's start by expanding this first. Now, you could use exponent rules if you wanted to, but I noticed that a lot of people over the years like to expand it and just cross stuff out because it's easy. So, we're going to keep the 3. X to the 5th is how many x's? It's 5 x's. So I'm going to do x times x 5 times. Y to the 6th is how many y's? 6. So y times y, and I'm going to keep going till I have 6 y's. How can I break down 6 into 2 factors? 2 and 3. So 2 times 3. All right. X to the 8th. How many x's is that? It's 8. So I'm going to do 8 x's. And then y cubed. How many y's is that? 3. Now, here's where we can have a little bit of fun with this. Anywhere we see a number or value that happens in both the numerator and the denominator, we can cross out. So I can go ahead and cross out the 3's. They're gone. Now, we don't cross out all of the x's. Every cross out, it's 1 to 1. So 1x in the top for 1x in the bottom. All right. So how many x's could I cross out total between the top and the bottom? 5. So 1, 2, 3, 4, 5. So the leftover ones we leave alone. Same thing with the y's. How many y's can I cross out between the top and the bottom? 3. So 1, 2, 3. So what I'm left with is y times y times y over 2 times x times x times x. Well, now let's simplify that. If I have y times itself 3 times, what's that the same as? Y cubed. We leave the 2. If I have x times itself 3 times, what's that the same as? X cubed. Now here's my answer. Now, if you didn't want to expand it, you could have also done the exponent rules. So does anyone remember how we divide exponents? You just subtract them. All right. So in my opinion, whenever I do that exponent rule, I always do the big minus the small. And then whatever I get, I put back where the big was. So let's look at the next example. I'm going to do that for that one. So first off, 20 over 4 simplifies down to what? 5 over 1. Now, the x's, I have x to the 10th over x to the squared. So if I subtract those, that means I have x to the 10 minus 2, which is what? X to the 8. Now, I need to put that x to the 8th on the side of the fraction bar where it was originally. Put the phones up. All right, so wherever the big exponent was originally, that's where I'm going to put that x to the 8th. So where do I put the numerator or denominator? Numerator. So we're going to put x to the 8th up here, and nothing goes back to the denominator. Now, y to the 8th, since there's nothing to divide by, we leave it up here. Now, this entire fraction is over 1. So what truly is my answer? 5x to the 8th, y to the 8th. All right. Try letter C on your own. So pick whether you want to do the expanded version or the exponent rule. All right, whichever one you prefer, that's the one you can do. So try letter C on your own.
was the question. Should we have a question or do you have a question? So we just need that. I'm not here. I'm just confused about the seven.
So once you think you got an answer, share with the group. All right, guys, let's come back together. All right, so let's start with the numbers. So remember, the numbers you can just divide on your own, or if you expanded it, you can cross out. So which do you want to see? Do you want to see expansion or do you want to see exponent rules? All right, so we'll start with the numbers first. So 7 over 21 simplifies down to what fraction? 1/3. Then the x's. X to the third over x to the fifth. So remember, I do big minus small, so 5 minus 3, which is what? X squared. And then I put that x squared back where the bigger one was. Where was the bigger one? Numerator, denominator. Denominator. So this would be x squared. And then the y's. So y over y to the 8th. So I have y to the 8th minus what? So 8 minus 1. Unspoken 1 here. So that'll be y to the 7th. And where does it go? Top or bottom? Bottom. Now, since everything is in the denominator, we cannot write this as 3x squared y to the 7th and call it a day. We have to keep the 1 up at the top because it's in the denominator, not the numerator. So if I clean this up a little bit, this will be 1 over 3x squared y to the 7th. And that's it. Any questions on simplifying the monomials? All right, let's look at simplifying ones where we got to do some more factoring. So I'm looking at the next page, letter A. So the first thing that we have to do is factor both the numerator and the denominator in order to be able to cross stuff out. So which one would you like to simplify first, numerator or denominator? Denominator. I would simplify denominator first because that one looks like it's going to be quick. So how would I factor the denominator? It'll be x plus 2, x minus 2. Why? It's a difference of squares. All right. So guys, when you're doing this, have that graphic organizer on hand because I'll allow you to use that on your test. If you forget how to factor something, look at that graphic organizer. So if you have a binomial, meaning two term, it's either going to be a difference of squares, a simple GCF factor, or possibly a sum or difference of cubes. Those are the only three options. All right. Top part. It's a trinomial, so we're going to have to do big X. What goes on top of my big X? We have A times C. So what's A times C in this case? Negative 14, and we have the X squared. What goes on the bottom? 5X. Now, we know my factors, if in order for it to multiply to X squared, add with a combined like term of X, that means they both got to end with an X. Now, remember, we need two numbers that multiply to get negative 14, add to get 5. So what are two factors of negative 14 that would add to get 5? 7 and 2. All right. Because remember, if we're multiplying to get a negative number, that means one of our answers has to be negative. And since this 5 is positive, the 2 is the negative one. And then I can put that into my reverse box. So remember, you look back at your original. X squared always goes in the top left. The constant goes in the bottom right. And then your two factors that you found can go in either of those remaining two spaces. And then it's just finding GCFs. So what's the GCF of this first row? Just X. Second row? Now it starts with a negative. So I said if it's the first term, then there is a negative, you should always make it what? You should always pull out the negative. Negative 2. Good. What about this column? X. This column? Positive 7. So this factored would be X minus 2 times X plus 7. So I now have both of these completely factored. All right, so now I can start crossing things out that I have in common between the numerator and denominator. What's the only factor that I can cross out? X minus 2. So I'm left with X plus 7 over X plus 2. Now, be careful because you may have a gut feeling to cross those X's out. Why can I not cross those X's out? Well, it's because they're factors, but there's something that's keeping us from breaking them apart. There's a specific sign, the plus sign. All right, so that plus sign between the X and the 7 and the X and the 2, that means that those bad boys stick together like glue. All right, so the way I explain this to students is up here, X minus 2, X plus 7, they're being multiplied together. All right, same thing down here. And we can cross these out because technically we're dividing this by this. I like to say multiplication and division are a little bit more open in the relationship departments. All right, they're okay with going with different people. All right, may have side chick to go off with. Okay, whereas the pluses and minuses, they are married. And I mean, like, do not believe in divorce marriage. You cannot separate them if you try. All right. May not be the happiest marriage, but they still ain't gonna break up. All right. So they are exclusive. They will not break apart. All right. So just remember, multiplication division. They're a bit more of an open relationship, whereas addition subtraction, they're a bit more of an exclusive relationship. All right. That's the best way I've always explained it, and I can guarantee y'all will never forget that because of the way I explained that. All right. That's why I explained it that way. Because as soon as I start talking about side chicks and open relationships, it sticks in your brain. So this would be your final answer. All right. Let's look at letter B. So letter B is actually a pretty easy factor for both the numerator and the denominator. What's true about the numerator of letter B? What type of factor is this going to be? It's going to be a difference of squares. So y'all had that one in your factoring practice a couple times. It popped up. All right. So remember, we first identify A and B, or A squared and B squared. So my A squared is 4x squared. My B squared is 1. You then take the square roots of them to get A and B. What's the square root of 4? 2 square root of x squared? X. What's the square root of 1? 1. And then all you do is that you're going to write out two factors using A and B, where one is going to be separated by a plus, the other is going to be separated by a minus. That easy. You just got to be able to recognize that it is a difference of perfect squares. And again, some of you, and I talked to some of you about this when we were doing the activity, if you don't recognize that that's the difference of squares, you're more than welcome to do a reverse box. Your B value is just going to be what when you do big X? 0. All right. So if you set this up using big X, the way you would set it up is you'd have 4x squared on top, 0x on the bottom. So what are two factors of 4 that would add to 0? -2 and +2. All right. That should be -4x, my bad. All right. So you could also do a reverse box that way. It does not matter. Now, the bottom. What's the only thing I can factor out the bottom? A GCF of 5. So if I divide both of these terms by 5, what am I left with? 2x and what? -1. So guys, just because I divide this by 5 does not mean that it doesn't exist anymore. We got to put that 1 there. All right, now, where's my swingers? So, which factors are swinging? I can guarantee y'all will never forget this. So what do I cross out? The 2x minus 1s. Anything else I can cross out? Nope. So my answer is 2x plus 1 over 5. Shh. All right, now this last one. So the numerator is going to be a bit of a more difficult factor because the a value is not 1. All right, but still same process. But let's factor the numerator first because that's an easy factor. What's true about the numerator? Not the numerator, the denominator. It's a difference of squares. So if I take the square root of both of those and separate them by plus and minuses, what will my two factors be? X what? X plus 4 and X minus 4. Good. Is everyone following how I'm factoring these? Okay. Now, This top one, we got to do a nice old big X. All right, so remember, A times C goes on the top. So what's my A times C of the numerator? So if this is A, B, and C, what's A times C? 24x squared. What's my B? 14x. And remember, we know that if we wanted to multiply to x squared and add to have a like term of x, both these terms have to have x's on them. Now, what are two numbers that multiply to 24 but add to 14? 12 and 2. Good. So now I can set up my reverse box. So I have the 3x squared in the corner and the 8 in the other corner. And then my two factors that I came up with in either one of the last remaining boxes. Let's find some GCFs. So what's the GCF of this first row? Just x. What about this row? It's 4. So this would be x plus 4. What's the GCF of this column? 3x. GCF of this column? 2. So my two factors are 3x plus 2 and x plus 4. Which ones can I cross out? X plus 4. Those are gone. What am I left with? 3x plus 2 over what? X minus 4. Any questions on some of those basic ones? All right. Now, one last thing I got to talk about. All right. It is when you have expressions like x minus y and y minus x. So, for example, if I had, you would see that sometimes if you had x squared minus 4 and then 4 minus x squared. So, in other words, they just flip-flopped. The problem is, will those two factor the exact same way? In other words, do I get the exact same factors? How would this first one factor? It's a difference of squares. So how would it factor? X plus 2, x minus 2. How would this one factor? 2 plus x, 2 minus x. Are these equal? Yes or no? Look carefully at the signs. No, they're not. These two are equal because addition is commutative, but these two are not. Because if I rewrite 2 minus x, that's the same thing as negative x plus 2. All right? So you got to be careful because they like to throw those at you. Okay? So let me ask you this. What is a way I could make these two look exactly the same? Could I factor something out of one of them to make them look the same? Because isn't the only difference is the signs are switched? So how do I typically switch signs? You multiply by -1 or divide by -1. Meaning I could factor out a -1. This becomes x minus 2. All right. So if we looked at these fractions real quick, 9 minus 6 is 3, -3, -1. 15 minus 3, that's 12. 3 minus 15 is -12. Still get -1. So what do you think will be with this one? Pretty much set up the exact same way as the other two. So what do you think my end result will be? -1. because we have a minus b. If I rewrite this, this will be negative a plus b. So this is a minus b, and I can factor out a negative 1 to change those signs. So negative a minus b. What can I cross out? What can I cross out? The a minus b's. So this would be 1 over negative 1, which is just negative 1. So sometimes we got to kind of finagle our way to look like what we need it to look like. And that can be put the phones up. And that can be, anything as just pulling out a negative, just to switch the signs to look like the way we want it to. So let's look at these last two problems. All right. How would I factor the top? What's the only thing I can pull out of the top? A 2. So if I factor a 2 out from 2x minus 10, what am I left with? X minus 5. Now, the bottom, all right, it's a difference of squares because they're both perfect squares. So a squared is 25, b squared is x squared. So if I take those square roots, what are a and b? So what's the square root of 25? 5. Square root of x squared? X. So this would be 5 plus x, 5 minus x. Now, what I like to do is I always like to rewrite it so that the variable is always in front. All right. And you can do that as long as you keep the signs consistent. So if I rewrite this, this would be 2 times x minus 5 over x plus 5 negative x plus 5. Now, as it stands right now, can I cross anything out? No. But could I manipulate a factor using the process that we just talked about to make another factor that I could cross out? Right, I can manipulate the negative x plus 5. And the way I can do that is by taking a negative out. So I'm going to rewrite this as 2x minus 5. I'm going to put the negative up at the front. We didn't take it from the x plus 5. But if I take the negative from here, so I divide both of those by negative 1, what do I have left? What's negative x divided by negative 1? X, and then minus 5. Now, do I have stuff I can cross? Can I cross anything out now? Yeah, what can I cross out? Good. So I'm left with 2 or negative 2 because that negative, if you have a negative, it can go in the top, it can go in the bottom, it doesn't matter. All right, so I have negative 2 over x plus 5. So it'd be this one right here. Do you guys understand how you use that negative manipulation-wise? Yes, no, maybe? All right. Okay, last one. We'll do this one together. Let's factor out the denominator first. What can I factor out the denominator? But before we even do that, let's rewrite the denominator so that the x's are in the front. All right. So I'm going to rewrite this as negative 6x plus 18. Because this then makes your factoring easier. Because what did I tell you do if your first term is a negative? If your first term is a negative when you're factoring, what did I tell you to do with that negative? Take it out. So when I factor the bottom, I know I'm going to have something negative. And then what's the GCF of 6 and 18? 6. So we're taking out a negative 6. So what am I left with? Good. So that's why my recommendation is if you see this, go ahead and write it in standard form, meaning put the x values first. because then it makes your factoring so much easier. Because then my rule applies when I told you guys if the negative's in the front, you take a negative out. So you don't even have to go through the whole manipulation thing. You can do it in one fell swoop. Now, how would the top break down? So if I do 8 times c, I get 9x squared. B would be negative 6x. So I have 2x terms. What would add to negative 6 but multiply to 9? Negative 3 and negative 3. So, just for time's sake, this will give us x minus 3 times x minus 3. Or x minus 3 squared, doesn't matter. So, what can I cross out? I can cross out x minus 3's. How many? 1. So I can cross 1 out from the top, 1 from the bottom. So, they like to move the negatives to the top. So this would be negative x minus 3 over 6. Which, what can I do now to simplify that further? What can I do with this negative? I could distribute it back. This would be negative x plus 3 over 6. Which, if I don't want to put my negative first, I can write this as 3 minus x over 6. So this one. Any questions on simplifying? All right, so there's no new assignment. All right, still just the factoring one. You'll get one tomorrow because they'll cover the other part of this lesson, which is multiplying and dividing. All right, but still similar process. So continue practicing that factoring. So keep working on that factoring delta math. The better you are at factoring, the easier this unit will be. All right, so keep practicing factoring. Even if you want to work through that factoring packet, all right, I'll post a key to it. I think